minus 3 plus 1. Let me step back and look at this. Does it factor? I lucked out. Is it factored? Does it factor correctly? Or you could use quadratic formula. Now you know, in addition to this, you know the x-intercepts are negative 1/2, 0, and also 3, 0. You place those also in your grid, and your graph must pass through those. Y-intercepts will be easier. A quick way to find the y-intercept, we went through all this last week. It comes down to f at 0. In other words, replace all the x's by 0. If I do, easily seen, it's 3. And there's your y-intercept. Whew. Yes or no? Then that should be enough to get you a nice sketch of this parabola. Does anyone see anything wrong with it? I did it quickly. Okay. Now, before I leave this one, this one's finished up. Before I leave it, part C. I thought, in preparation for today, I had better, I hope I did, better show you something that may happen. I may have the graph drawn for you in a particular exercise. I may say quickly, on a grid, you have this. Now, I brought one in, I'll need your help here. The parabola looks something like this. Sketch for you, drawn for you. I am going to give you some information. This turning point, vertex. I label this as, in my example here, out 1, up 4. I need to write the equation for that given graph, that given parabola, and I'd like for it to be eventually placed in this form. Now, I need a little discussion to close this down. This is all a recap. Can anyone tell me, do I have enough information right there at the moment on this sketch to write the equation, the function for this parabola? I have the vertex, that's the h and the k. I can do at least that much, I think. Yes, go for it.
No, because you don't have the x and y intercepts, so you can't determine stretch.
Okay, the x and y intercepts, thank you. I might need those, Absolutely. Let's go back. You say, Professor, the vertex form is right here. You gave me the vertex. So can I at least quickly replace the h and the k to get this in the vertex form? Anyone tell me, as I write this out, y is equal to a, that says x subtract h squared plus k. What would I place inside here to make sure I get 1?
X minus 1.
X minus 1. And you get the 4 plus 4. Do we have that much right there? Done. What's missing?
Negative.
Yeah, about negative something out front, because I know it opens down, so there's going to be a negative. Is it negative 2? Is it negative 1/2? Is it negative 10? It's negative, but I need to know the specific number, negative. You want to have an idea? Go for it.
Could we input the vertex values? in
I think
separate
I'll just
A?
take it back to where we started.
Okay.
You need more information. I didn't give you enough information, I just gave the vertex. So I threw in an additional point, and I made this one fall here. Let's call this point right here. On the parabola, its coordinates are -2 down 3. Now, I guess I'm going to be clever and tell me, what might I now do with this additional information, additional point, to maybe come up with what A is? Go for it.
We know what X and Y equals, or so we can solve for A?
Okay, so you're saying this is my X, this is my Y. You're saying, Professor, why don't I just go over it where you stop and replace X and Y by those numbers from those coordinates. So Y is -3, A is missing, X subtract 1 squared is fine. -3, -2, now, -1 squared, plus 4, we step back. So guys, I took these coordinates with his suggestion and replaced the X and the Y with the coordinates. Now, do we have enough now to solve for A?
Yes.
I think we do. It's -3. We all know that's a -3, but when you square it, that's 9, so it's 9A plus 4. Solve this simple equation. Looks like A is equal to -7/9 if I have no mistake. Yes or no? Now, do we have the negative that we're looking for? Some students may say, Professor, can I just place any negative number that I wish? No. I'm not satisfied with this point. I'll get the point to you. Yes, go for it.
When we, establish that it's, negative because obviously it's upside
Uh-huh.
down, you don't have to put the negative sign into the equation before we input the X and Y values?
You mean back up here?
Yeah.
No. Now, these two here, negative, had to go in as negative, of course. Okay, guys, with me? Do we all accept this? Now, if I should, Andrew, if I should ask though, before you turn your quiz in tomorrow, if I should say, great, I love this, who on earth of all the negative numbers in the universe, this one required -7/9. You had to be negative, the 7/9 of all, that's it. Andrew, what would you have to do, I'm not gonna do it for you here, what would you have to do though if I specified, don't leave this until you have in the standard form?
Complete the vertex form and then transform it back into the quadratic form.
Absolutely, just go up here and say, Professor, you have this much, Y is equal to, you just discover the A. And X subtract 1 squared plus 4, he says, Professor, it may take a little effort, but I need to expand that out. Is that true, guys? This is gonna take a little effort. But you multiply it out and make it now look something like, where am I? This. Wow. We were doing that last week. Welcome back. Welcome back to Math 2. We're back. Okay, any concerns there? Anything at all? Now, remind me, did we have a couple of application problems? I think there was one with a fencing problem. They wanted to fence in a piece of ground or something. And also, I think there's one where we tossed something up in the air. We had to find the maximum height, so forth and so on. Okay. Word problems are going to be easy now for me. If you see the word maximum or minimum, you're going to turn immediately to that. You don't have to go through all this completion of the square again. You're going to turn immediately on an application problem to say negative b over 2a will give me a start on finding that maximum height or that maximum area. And I think on a handout we worked out 2 of those problems, didn't we? Last week? I'm sure we did. Guys, look at it. How's it look? Now tomorrow, one problem. That's just one problem. One problem. Like this. Just like this. I'll give the function to you. I'll give this to you. Then I'll ask you to go through all the completion of the square, graph it. Did we find, yeah, we found the x and y intercepts, didn't we? Yeah, we found the x intercepts being what, these two? So mine drawn, I drew it quickly here, was -1/2, when the curve should have been -1/2 over here, and a 3. Is that true? And you can also find the y-intercept. I think we did. Then you put all that business together and have your graph. Guys, any concerns here? Now, you say, Professor, what else? Are you going to throw an application problem on here? Of course I could. The application problem now should be easy for us. If I ask you for find maximum number of feet to be enclosed, you can do that easily. But I'm also very, very, very concerned where I need it. Let's see, what else was I concerned about? Yes. If I give a function to you, make it up real quickly. See, it looks like that. By the way, would you identify this as a quadratic? A little strange.
Yes.
That's some strange coefficients. And I asked you, it should graph into a parabola, it should. Now, suppose I say, don't graph it this time, don't go through completion of the square and try to graph this, as we did earlier. I may say on the part of the quiz tomorrow, take this, no graphing required. Tell me, is there gonna be a max or a min first? In this case, of course, we know there will be a max. No graphs. Now, so to ask you, what is the maximum value that this function will take on no matter what you replace x by? There's a maximum value that this function takes on. Can you find it without going through all this business? Who has an idea?
Use the vertex formula.
Yeah, that's why it's there. Use the vertex formula. The x in this case, we're going to use the x here, that's negative b over 2a. And guys, my strange coefficients, that's negative square root 5 over twice a negative 1/2. Do not let me make a mistake there. Is that true? So it looks like it's positive radical 5. Oh my goodness, a negative radical 5. These cancel. I think altogether it's negative. Is it negative radical 5? I did it quickly. Is it? Is that true, guys? You think so? Now the question is, though, what is the maximum value that that function takes on? You say, well, Professor, I know when it takes it on. It takes it on when x is this number here. So I could go back and replace these x's by that and find it. Or I could use, as Andrew says, I could use, where is it? This. To find the maximum value. Let me just go ahead and plug in. Rather than use it for AC business. Now let's take f of negative radical 5. I think it's going to be pretty nice. If I put it in correctly. Step back and look. Something like that? I hope. Now, why is it going to be fairly nice? Because I think this, guys, right here, when you square it, just that, is that 5. And the a half out front, so make that what? Negative 5 over 2, I guess. Let's step back and look at it. You guys agree? Is it 5 over 2? Negative. This, not too bad. A negative times a negative is a positive. Radical 5 times radical 5 is merely 5. And of course, you got your plus 6. Add them up, do the arithmetic. You can use a common denominator if you wish. And I'm going to end up with negative 5 halves, plus 10 halves, plus 12 halves. Looks like 22 subtract 5, guys, what is that, 17? I'll do that real quickly. Is it 17 halves? I did it quickly. 8 1/2? Now what does that represent? You can sit there all day and replace x up here by any number you wish. The highest number coming out, no matter what the x is, will be this. 8 1/2 is the max coming out for that function. Okay, guys. I think it's a good recap. I did in what, roughly half an hour. Any concerns? Questions? Okay, for our races, because I'm moving shortly into chapter 3 here, shortly. Look at all this business here. Make sure you know your stuff. I'll be here tomorrow. I think tomorrow's my day to be here. I'll be here. I think it's going to be beneficial for you as you did for that exam. And you guys all showed up at 11:15 that morning. I think that helped. So I'll be here tomorrow, 11:30. Here, 11:30 tomorrow. Any concerns here? Questions? No. Andrew, you help me out here. First, guys, if I give this and say no sketches needed, don't complete the square. Just tell me the maximum or the minimum, could be minimum, value that this function will take on. And he says, Professor, this is it. Use this. They'll tell you the max goes in. Before I leave it, I shouldn't do it, but here it goes. Anyone tell me, for a little extra credit, you saw extra credit. If this is the graph, I threw the graph together real fast. So I'm going to ask you now to sketch, real quickly before I erase this. Let's call it G of X. See, the game's put up already. I want to see a sketch of the absolute value of this function whose picture is, whose graph is this, I notice I've drawn the scale. And all I want to know is roughly what would that absolute value do to the graph? Yes, sir.
It'll reflect up, it will go up,
Again, what's gonna go up?
so problem.
Are you saying it's gonna just flip over like this?
Yes.
Like this? Not quite. I know what you're thinking, but not quite.
It becomes an upward facing V graph instead of a parabola, 'cause it's an absolute value.
Okay, tell me, Andrew, before I leave you, would you tell the class with what you described, is there any piece of this blue parabola satisfying the absolute value already?
The vertex?
Look. There's one part of that blue graph that I need not change. It satisfies me applying this. Yes.
So the values that are above the x-axis, they don't have to.
Look at this. She said, Professor, this piece of the parabola is above the x-axis, implying it's positive. And should absolute value always can be positive.
Yes.
Now, we're concerned about those little two pieces below the x-axis, which are in negative territory. I can't leave them down there. Yes?
Those are gonna flip up to have the same x values, but be the positive coordinated y values. So
Now,
it's
how am I
be-
gonna get, for example, how am I gonna get this piece, which has to be moved, it's below? How am I gonna get this piece out of that negative territory into the positive territory that an absolute value should do? What should I do here to move that?
It's gonna be like the piecewise function you showed before, where when it's less than 0, it's negative x.
Somewhat. Let's think about something else.
Okay.
There we go. A reflection? Was there, I heard a reflection? Can I just reflect this, what, across the x-axis, I guess, or something like this?
Yeah.
And then this piece down here has to go. And if I do that there, up here, guys, it looks something like that. If I reflect it? Or are the pieces above the x-axis now where they should be? So what's the final graph? The final graph is all this. It's this that I had to do, this was part of it already, and this. This up here represents the absolute value of this function. Jeez, I'll get carried away here. Okay, close it down. Close down that. Now, we erase all this. I think we have everything done here. Okay, part two, I guess. value inequalities. Now, I don't know how much you were thinking about absolute value inequalities on your little break. I don't know whether you were walking around saying, boy, I love those absolute value inequalities. I love the way they work. But we did those. Letter A, if I saw this, can someone please tell me, what does that mean? And we were looking at it, I think, through a graph. The absolute value of X is less than A. Anyone translate that for me and tell me, what does that mean?
X less than 8 or X more than -8.
Okay, and I'm gonna write like this. Just tell me in essence, X has got to fall between a negative A or a positive A to satisfy that inequality. Now, I think we did it on a graph. I think this is one where we looked at the graph, where it was the graph below the X-axis. We also had this one, I gotta be careful with. This one means, someone's going to be very, before I leave the blue, before I leave it, I love what she gave me. In interval notation, if you need it, it's the same as saying this. Now, how about this one? This one's a little bit more tricky. Yes?
Is it negative infinity to negative A and then A to infinity?
You guys remember doing this? Last week? Guys, was that the translation? We did by looking at a graph. I think all that's in your notes, I think. Now, can you tell me algebraically, what's another way to express this? If I say negative infinity up to a negative A, what's another way to express that? What does that mean? You're trying to tell someone what that means. What does it mean? A negative infinity up to a negative A.
X less than -8.
Hang on.
and-
Perfect. Or?
Or X more than
Absolutely. That's exactly what it means. And the student gave it to me in interval notation, which is fine, but actually means this. This one means this. Don't confuse the two. We looked at those last week. Now part B, just real quickly. I did this before the handouts come out. Beautiful. Yes. I'd like to solve this absolute value inequality there. Absolute value 2x subtract 1, I guess it is, less than 6. There's a way, Professor, I had better go back and see which of these two forms this fits. And it looks like that less than symbol, it fits that first form. Therefore, I could quickly say, here's what I need to use in blue. I need to rewrite that using the blue. In this case, A is 6. Guys, let's write this as put in blue since I'm in blue there. This means -6 is less than, be careful, 2x subtract 1 is less than 6. This, are you being used on this? Does everyone agree? Very easy. Supply the definition. And to solve for x, I'm going to add 1, add 1, add 1, make it easy on myself here. This is a -5, less than, these drop out, 2x, less than, looks like 7, I'm doing it quickly. Divided by 2, and there's no mistake. There's your answer. I'm going to place it in interval notation, my answer, and that means it's written in this form as an interval. You're finished. You can't go wrong. You can't not go wrong. If you have only these two choices. We'll try another one here. Part C, let's solve this. let's throw a negative number in here. Let's try that one. Together. Have only two choices. This one, with that greater than and greater than sigma c, means I should be applying this one, this formula. Which in interval notation was given to me like this. Here's the other way to express it. So guys, we use this like a definition. It says go over there and express x is less than negative a. Can anyone tell me, be careful, what would this look like using this so-called definition? Let's get the first part of the definition. What would this look like applied to that problem? Anyone?
Maybe 3x plus 4 is less than negative.
I love it. That's exactly. This, translated over here, tells me that. Or, you know where or, now you gotta express for this part of the definition. It says x is greater than a. Oh, by the way, let me throw the equals mark in on this one, there was an equals. Now what does the second part look like? Based on my problem.
More.
Negative 3x plus 4. This time what?
More.
There you go. This is applied for the definitions. And then try to solve each one. Now I gotta be careful here. To solve this one, let's move that 4 over right quickly, subtract 4. Right? You went into the negative 14. Divide by negative 3, reverse your symbol. X is greater or equal to positive 14 thirds. Do not let me make a mistake. Solve the next one. It's going to be a negative 3x. Move that 4 over, subtract it, that's a 6. Divide by negative 3, reverse. And looks like I'm getting negative 2, and I did that quickly. Is that correct? Woo! That's your answer. Now, if I say express it in interval notation, because well, professor, you want this. You want bracket 14 thirds through infinity. Yes or no? Down here, x is less than or equal to a negative 2, guys. Someone help me out here. How can I express in interval notation x is less than or equal to a negative 2? Negative 2 or negative infinity? That's right, negative infinity. Up to and bracket. Wow. So there's your answer.
We're not writing unit or
You can put a union here. That's no problem. The word or that sometimes union.
You don't have to do on that too, right?
No. As long as you have the two intervals for me. In other words, you want this one first. And then this one. You could. Pretty good, guys? Now watch my time here, because I gotta move into chapter 3. But I cannot leave this until this. I'd like to solve, and I may just set this up for you. Looks like this. What a problem. Oh, what a problem. We'll close down this. That's 4x subtract 2. Ooh, this will be nice. Somewhere in this clever class, I had 10 A's in that exam. Talking to my colleagues, they had maybe 1. There was some good, solid students here. Can anyone tell me, I just remember the first time you've ever seen one combined like this. It's a combined inequality. Anyone tell me what you might, as a clever student, do in an attempt to find the x's, x values, that when you replace x by this and do all this calculation in the middle, you're guaranteed the answer falls between -9 and a -1. And just at random, we throw a number in, just at random, 0. 0 work, Professor? Let's put a 0 in here. 4 times 0 is 0, 0 subtract 2 is -2. Absolute value gives me a 2. 2 times 2 is 4. 3 subtract 4 gives me a -1. It gives me exactly -1. I did not want -1. So I can't use 0. Could I use just at random or try 5? Would 5 work? Let's put 5 in here. 4 times 5 is 20. 20 subtract 2 is 18. Absolute value, of course, is 18. 2 times 18 is 36. 3 subtract 36, I think it's a -33. Is it? Did I do that quickly? I think I put it at 5. Did I say 5? 20 subtract 2, I guess, what, 18? 2 times 18 is 36. And then 3 subtract 36. Is that -33? I think I did quick. Is that -33 altogether? Does -33 fall between -9 and a -1? No. So I can use 5. But what can I use? That's what the question is, find the numbers that you can use. And they want all of them. Not just randomly sit there and try until you find one. Go for it.
Isn't it all numbers between 2 and 1?
Okay, now if you say all numbers between 2 and 1, oh boy.
Like 2 is greater than x and x is greater than 1. If you like solve it out.
Wait, x is greater than 2?
X is less than 2.
Okay.
And then x is greater than 1.
So you actually
all
said that-
those digits.
Are you saying maybe something like that?
Well, I solved out the middle part, and then I got my x value as 2 is greater than x, x is
Oh, so you went ahead and solved a little piece of this.
yeah.
Hang on. Now, if I jump in and pick up where Andrew left off there, anyone, I'm randomly selecting numbers. My 2 numbers would not work here, 0 and 5. There's one thing, so you know a number that would work, just at random, replace x by that random number and I'll check it for you. Anyone have? Maybe, and I'm sure when we finish this up, there's an infinite number of them. I need one. Anyone give me one random number? And that's what we check. Replace x by this right here. My 5 didn't work. My 0 didn't work. But one works. Makes no solution. Yeah. 2. Let's try 2. 4 times 2 is 8. 8 subtract 2 is 6. Absolute value is 6. 2 times 6 is 12. 3 subtract 12 is a -9. What messes me up? There's no equals mark there, so I cannot include -9. Oh, we were close. I cannot include -9 because there's no equals mark there. Andrew?
Let me try 1.5.
Whoa, this is going to be a fraction. Okay, let's call it 3 halves.
Yeah.
It'll be easy. I can cancel 2 into 4, get a 2. 2 times 3 is 6. 6 subtract 2 gives me a 4 altogether. Absolute value of 4 is 4. 2 times 4 is 8. 3 subtract 8 is a -5. Now, does -5 on a number line fall between -9 and a -1? Andrew, congratulations. 3 halves works. I'm telling you ahead of time though, I think there are an infinite number of possibilities besides his that will work. 5 halves works. 3 halves, sorry, 3 halves. Guys, let's find all of them. Andrew, I think Andrew's was saying, Professor, I'm gonna jump in and do a little algebra here first. Like what? Clean up. Subtract 3. Subtract 3. Subtract 3. This is -12. These cancel. These do this. Less than -4. Do not make a mistake. Carry away here. Now it might be wise to do what? what do you have in next
Divide by
thing?
minus two.
Thank you, divide everything by -2.
Yes.
Okay, divide everything by -2. And of course, that's gonna be a 6. Uh-oh, this turns around. These cancel. These do this. Turns around, 2. Now,
Can you split it into two separate little columns?
thank you. She's a professor, you've already done that cleaned up. We're down to here. She said, Professor, could separate those two for me. Because I know, Professor, eventually you're gonna go back over to these 2 parts. So I'm gonna go ahead and separate this into 2 parts. One will be, if I go straight from left to right, it says 6 is greater than this. And if I separate, the middle is greater than 2. Guys, look at the blocked off portion. Did I separate it correctly into the 2 parts? Now, class, tell me, does this one on the end, can I apply directly this? And what on the end, the one on the end, does it now look like, could I apply the second definition here? Absolute value of x is greater than a, could I apply that now to it? So let's go to the end down there and apply it. Now, can someone tell me, I'm gonna get this out of the way right now, this part. Looks like what if I apply this, which means this? Woo. 4x minus 2, hang on now. More than, greater than, or where am I? Let's get the, let's get this part done first, this one. Less than, what, -2? Or, right here, 4x minus 2 is, read, you read that. Thank you. You guys agree? She applied that. Now let's stick that in the red and get it done. Let's solve this, guys. This is 4x is less than, I'm solving this, I think 0. How cute. X is less than 0. And this one down here is not too bad either. 4x is what? Greater than 4? X is greater than 1. Oh, nice. Don't make a mistake. That one on the end's done. Those are my solutions. Now, how about the one that I have not yet worked? This one. Anyone tell me, look at this first one, which I have not solved yet, and I'm trying my best to go back to these 2 definitions. Can I apply one of those definitions to it directly? The way it looks like this. My definitions look like this. Can I apply directly one of the definitions to that first term, which I have not dealt with yet, this? If not, why not? Give it to me.
Maybe we can divide it in just the easier form for 4x minus 2 less than 6.
Hang on now, she says, Professor, can I turn that around? 6 is greater than that absolute value. She says, Professor, that means the same as this. Turn around. These 2 actually saying the same thing, just turned around. Now, since she turned around for me, now can I say, oh, it looks more like, where is it? This. Now, can someone in the blue here help me? Use form number 1 over there and tell me what that looks like using that form, and then I'll solve it. And here's what I'm asking. What does that look like over there? Go for it.
-6 is less than?
-6 is less than?
Yeah. Then 4x minus
Thank you, and
2, and which is less than 6.
look at that. You applied that perfectly. And then I can solve this. Okay, guys, to solve it right quickly, I don't know how quickly it's moved here. Add two, add two, add two. We end up with a -4 is less than, these drop out. Don't be making a mistake here, please. 4x is less than, looks like 8. Let's step back and look at it. Woo! Then divide through by 4, -2, by 4, -1. -1 less than x less than 2. Do we agree? Please tell me, have I applied the formulas over there, definitions, and gotten both these out of the way now? Has it been done? You said, Professor, what's the final answer? Well, now you gotta look at this is part of the answer. And then since they were combined, this is, where is it? Another part of the answer. Now you gotta find what satisfies both. Good luck. And then I'm hoping that your 3/2, when I find what it is, I'm hoping your 3/2, we checked your 3/2, 3/2 should be in that answer. Now I need to get one interval that satisfies this and this. I gotta put these two together. Now I would suggest, this is me, I would suggest a visual, a little graph on the side here and say, Professor, you asked me to do this. Put them together. Let's put the blue one on the board first. The blue one says you're caught between -1 and 2. Place it like that. And at this point, it looks like this. And shade. Would we agree, guys? Is that a picture of this? Okay. Now you gotta put the red on there. Same grid. Put the red, or same line. The red one says x is less than 0. Guys, I think 0 is in here somewhere. And less than, if you guys will agree, are we talking about that? For less than 0. Representation. And then it says, now please pick up on the red 1. Oh, 1's in here. And it says greater than, looks like that. There's the blue one and the red one put together, as they originally were. This was, look at this, they were originally all together, wasn't a problem. I'll separate them. I've got to put them back together for the answer. Anyone tell me what the answer is? Or where on that red-blue business over there, where are you going to look for the answer? The answer's staring at you.
From -1 to 0.
To begin.
From -1 to 0.
Oh, look at this. He's telling me, Professor, you better look at where they overlap. The blue from -1 to 0 here, -1 to 0, is that also on the red one?
Yes.
They have that much in common. What else do they have in common, the red and the blue? From what, 1 to 2?
Yes.
Here, and 1 to 2 up here. Do they share that much? So my final answer to this crazy, crazy combined inequality is this. -1 up to 0. Union. I think we said what, 1 to 2? Oh, Andrew, I think there are 3/2, 1 and 1/2, it's caught. Right here. Right?
Yeah.
3/2 does work. Now, what else works? Lots of numbers. -1/2, -3/4, -5/6. Caught between 1 and 2, he gave me what, 3/2, 1 and 1/2, 1.7, 1.3, 1.8. Guarantee you, any of those numbers caught here or caught here, and you have the patience, you replace x by them, crunch it out, you want to satisfy this inequality. Wow. Could you do one of those for me? You say, Professor, really? Tomorrow? Not tomorrow. Maybe Friday? Could you do one of these? Could you take the time to separate them? And I know June, she sends out absolutely beautiful notes. I mean, have you guys noticed how she's so organized? Much neater than I am. Nice. She uses different colors and all that business. So look at her notes here on this. Because this was a crazy problem. Crazy problem. You go up to a student in grad school, MIT, they might be able to solve this real quickly. But it took us this much time. Whew. Concerns here, guys? I feel better now. It took me all my time here to recap. But I had to do it. Get back into where we should be. Guys, any concerns here at all? I think we've done a good job. Let's see if I wrote myself any other notes here before I get a handout to you. I don't know. I'm done. Now, I am happy to announce, here we go. Yes, when I picked these up this morning, just make sure they're all here. This one handout's gonna cover, and it's a thing for it, section 2.8, equations and inequalities involving absolute value. We just did inequalities here. Then 3.1's on here. If you flip it over, 3.2 is on here. When I finish this up, the other one I have here that I just picked up this morning has 3.3, 3.4, and that means chapter 3 is basically almost done. Now, can I do it?